Good evening to all. I welcome to all the participants to this international seminar, namely Current Trends in Green Chemistry. On behalf of Bhatter College, Dantan, today Department of Chemistry, Bhatter College, Dantan is organizing an international seminar on green chemistry in collaboration with Department of Physics and Mathematics, Bhatter College, Dantan. The name of the seminar is the Current Trends in Green Chemistry. Green chemistry is an important topic in present scenario. Green chemistry is a science-based philosophy of designing chemicals and processes with the intention of making them less hazardous and more sustainable. It applies to the life cycle of a chemical from creation to disposal. As we know that green chemistry is defined as the design of chemical products and processes that reduce or eliminate the use or generation of the hazardous substances. Its goals are pollution prevention and reducing waste and use of energy. In this international seminar, first as a convener, I declare the principal of this college, Dr. Pijus Khatua, as a president. Then I request to the principal of our college, Dr. Pijus Khatua, to deliver inaugural speech. Sir, over to you, sir. Please start your session.
Thank you, Subhankar. Good evening, all respected dignitaries, distinguished guests, fellow members, honorable scientists, professors, researchers, and beloved students. I am happy to be amidst you all and share my impression and thoughts on today's international seminar entitled Current Trends in Green Chemistry, organized by Department of Chemistry, Bhatter College, Dantan. Actually, this seminar for the cultivation of science, scientific knowledge, and thoughts and its application to human welfare. From this point of view, it is an important day for our college. Our beloved Bhatter College is situated at the southwest part of West Bengal, near Odisha state. This college had started its journey with 6 UG courses only in the year of 1963. Now, our college is enlarged. Here, 18 UG courses and 4 postgraduate courses are running in our college under Vidyasagar University. In this year, not this year, in 2015 and 2023, our college had accredited A grade consecutively by NAC assessment. And another important is our college has declared as Center of Excellency by UGC. Our college just one step behind to get autonomous status. Actually, the collaborative and cooperative teaching learning system among enriched and skilled professors and talented, hardworking students is the key factor of our all achievements of our college. Today, in this webinar, we have 3 invited speakers, and they are renowned resource person for us. Dr. Olakananda Hajra, Department of Vishwabharati, Shantiniketan, Birbhum, West Bengal. Second one, Dr. Subhash Banerjee, Department of Chemistry, Guru Ghasidas University, Bilaspur, Chhattisgarh. And third, Dr. Oikod Mukherjee, Faculty of Chemistry, Nicholas Copernicus University, Turin, Poland. They will discuss elaborately about the green chemistry and its application in mankind. I, Dr. Pijus Khatua, Principal Bhatter College, Dantan, on behalf of our college, heartily welcome to all the invited speakers as they have given us some time from their valuable busy schedule. Such type of interaction among scientists, researchers, students through sharing of knowledge could be highly effective on the way of future researcher and development program. From core of my heart, I welcome all delegates, participants, researchers, students from our country and abroad. I welcome to all the faculty members, staff members, students of our college, and especially to Dr. Subhankar Sardar, head of the chemistry department, for his great initiative. We are waiting for an excellent session, and I wish a grand success of this webinar. Thank you all. Over to you, Dr. Subhash Subhankar.
Okay, thank you, sir, for your inspiring speech on our college and the topic of the seminar, green chemistry. Now,
Thank you,
with the
Subhankar.
now with the permission of President, I wish to start formally the technical session of this seminar. At the start of this technical session, I wish to invite Dr. Olokananda Hajra, Associate Professor, Vishwabharati University, West Bengal. Welcome, sir, for your glorious presence. Although we chemistry people all know Dr. Hajra very well, but here many new students and faculty of other disciplines are present. Thus, before the start of this lecture, I wish to formally introduce Dr. Hajra. Dr. Olokananda Hajra, Associate Professor, Department of Chemistry, Vishwabharati, a Central University, Santiniketan, Birbhum, West Bengal, India. Dr. Hajra completed his BSc in Chemistry from University of Calcutta. After he completed his MSc from IIT Kharagpur, he has done his PhD from Indian Association for the Cultivation of Science in 2003. Dr. Hajra done his first postdoctoral research in 2002 at SUNY at Albany, USA, with Professor Frank M. Hauser. Then he did second postdoc from the University of Tokyo with the Professor Ichi Nakamura as JSPS postdoctoral research fellow. Then he completed his third postdoc from NTU Singapore with Professor Naohiko Yosakai. After completing his postdoctoral research, he returned in India. He joined as assistant professor in Department of Chemistry, Vishwabharati University in June 2006. He is now serving as associate professor in the same institute. He got several awards like Professor D. Nosipuri Memorial Award for the year 2019, Chemical Research Society of India CRSI Bronze Medal Award for the year 2018, Japan Society for the Promotion of Science Bridge Fellowship in 2018, and so many awards. He had published more than 200 papers in several international journals and wrote many books and book chapters. His H index is 52, I-10 index is 156, and his total citation of his article is more than 10,000. With this brief introduction, I invite Dr. Olokananda Hajra to deliver his lecture. His lecture topic is Green Chemistry, Perspective and Practice. Over to you, sir. Sir, please start your session.
Um, Thank you, Dr. Sardar, for your kind introduction. First of all, I would like to thank the organizing committee, especially Dr. Khatua, the principal of this college, also the convener, Dr. Sardar, Dr. Sahu, and Dr. Tarabdar for their kind invitation. And that is basically whatever as mentioned by the convener, the green chemistry, that is chemistry part is there, but there is another part is there, philosophy. uh, our convener nicely pointed out that that is a one kind of scientific philosophy. So I will discuss two part, where is the chemistry is there, and also the scientific, also the philosophical part. So as you know, every day we are going to like every day we are going to like a market to shopping something. But when we go, we are not thinking about bag. So just we are taking just plastic bag. So in our daily life also we need to think whether that is this bag reusable or not. That is also philosophical part. Other part is chemistry. Whether this bag is biodegradable or not. We need to think every day in our life. From childhood, from also like teaching part, we have to think whether that is a part of our philosophy or not. So I will start today. I will discuss little bit about green chemistry, what I am doing in our laboratory, also what I am teaching in Vishwabharati. Just I'm going to start. It is okay, Subhankar? No, maybe screen is not entire screen, right?
Sir, please make it full screen.
Okay, okay, okay. I'm doing little bit just.
Just click on the cup of tea in the symbol. Yes, yes.
Please do first enable editing, then you can click this one. First enable editing.
Okay, তারপরে এটা then
Subhankar, please.
it's okay. Hello, it's okay.
No, no, no.
No. তারপরে
Sir, please on the PowerPoint presentation mode.
It is okay, Subhankar?
Sir, click on the PowerPoint presentation mode. That is the
Subhankar, help sir. Where is the PowerPoint presentation mode?
yes.
Right corner.
Okay.
Click on that.
Okay, done.
No, 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 no.
Done. Hello, it is okay?
Mm, no, no, no. Sharing. Window,
No,
interesting.
sir. Share it.
Okay, okay.
No, sir, the screen is not seen.
Sharing in the entire screen.
Okay, share
In the entire screen.
entire screen. Okay, share.
হুম, এই সরেছে তো অনেকগুলো ডকুমেন্ট দেখাচ্ছি আর কি
It is okay?
হ্যাঁ,
Okay, sir. Start it.
It is okay now?
click on the here, click here.
It is okay?
Okay, okay,
Okay, sir.
okay.
Fine, sir.
It is visible now?
Yes, sir. Yes, sir.
Full entire screen?
Yes, sir. Sir.
Yes, sir.
click
Enter
on-
screen. Yes, sir.
Sir, click on the hide button. Thank you. Yes.
Are you okay now?
Clearly visible.
Oh, clearly, okay. Okay, I'm sorry. I'm sorry little bit. Anyway, so now I'm going to start. So, nowadays technology. So sometimes we need to also habituate the technology. Anyway, so now I'll deliver the lecture. I thank the organizer for giving me this opportunity. So just be patient for 40 minutes. I will discuss about the green chemistry part. What I am learned from my PhD as well as my postdoc. So as you know, first question is what is green chemistry? So simple answer is there, doing chemistry the way nature does chemistry. So it looks like simple, but that is an ideal synthesis. But in your real life, it's very difficult to do ideal. So as we are in Earth, that should be difference between ideal and real. So there should be always difference. So if I give you one example, that is the example photosynthesis. From basically what about now, we know the photosynthesis, what is the benefit, how it is doing. So as you know, carbon dioxide, water, in place of chlorophyll, and sunlight, we are getting basically carbohydrate molecule. That is basically what about now, we are getting this one. We are getting carbohydrate molecule and also oxygen. So while we are doing this is ideal. So as you know, carbon dioxide from basically nature, they are taking carbon dioxide and also water, chlorophyll, all tree, this kind of tree or this kind of thing, they have chlorophyll and sunlight. That is also available. After that, basically what about they are doing reaction and they are basically what about they are giving carbohydrate molecule, that is glucose molecule C6H12O6 and also oxygen. That is we need. So both things we need. Also basically what about that is if you just for the undergraduate student, as you know, that is basically reactant, that is product. So all reactants are consumed and they are giving the basically useful products that is for beneficial for the mankind. Also like chlorophyll, they are using sunlight, that is also energy, that we can say basically whatever reaction condition. So in nutshell, we can say that is basically this one basically reactant, that is reaction conditions, and also basically that is our product. So if you compare all products are useful to mankind, that's why we are telling that is basically what about that is ideal synthesis, but nature is doing. But how can do in laboratory, that is very difficult. But we need basically what about we need chemistry. Why we need chemistry? To meet the demand of modern civilization. We need variety of chemical inputs and chemical industry. A lot of product we need always. So as I told you, I am from Vishwabharati University. Our founder Vishwabharati was founded by Rabindranath Tagore, that is quite known to all. He is the first Asian Nobel laureate. He got Nobel Prize in 1913. Not only first Asian Nobel laureate, he is the first non-European Nobel laureate. That is very, very important. Nowadays, we are very proud that UNESCO World, that is the UNESCO World Heritage Center. So we are very proud for this one. So Guru basically heard about, he had some philosophical part about nature. He always wrote many poems, many things, also many things he did for the nature. So what do you think basically? So according to us, poverty is not problem so important. So what is the problem? It is the problem of unhappiness. So what are things, unhappiness makes our basically what of poverty. Poverty is not problem. What do you think? What do you think? He mentioned this one basically what about, just introduction to the Elmart book in Overview of Soil. He mentioned this one. So he was basically what about, he was very deep unhappiness at the systematic exploitation of nature by civilization. He always mentioned many things about Bikhoropon, so many things he mentioned. But what people are doing, modern civilization, they cutting these kind of things, he was very unhappy. He also saw transformation of real life through principle of cooperation between man and nature, man and science, and man. So used to these things. And other thing he wrote, village are waiting for the living touch of creative faith and not for the cold aloofness of science. So if you visit our Shantiniketan, there are two campuses. One is Shantiniketan, other is basically Sriniketan. He wrote this about Sriniketan. What he mentioned? He mentioned Tagore's ideal was to draw sustenance from nature, but sustain it too. What he wanted to tell, take from nature, but still you have to give some. You have to also give to nature something. But nowadays, what we are doing, we are taking everything from nature, not we are giving the nature. That's why he was very unhappy about this one. He also replaced it in a spirit of mutual cooperation and respect. It is this realization that brought him to the series of poems celebrating Bikhoropon, plantation of sapling festival. Nowadays, all over the whole India, now this kind of Bikhoropon plantation is going. But he started these kind of things from maybe 100 years ago. That's why this is very much important. That is a philosophical part. Sustenance from nature, but sustain it too also. Take from nature. How do you just take from nature? Also, you have to give some nature. That is mutual cooperation. That is very much need nowadays. So what today's society, that is a very famous cartoon. So how do you think all people, all four people are in a same boat? But these two people think that they are in danger, and the other two people, they are other end, they are not danger. But nowadays, whole planet, whole country, whole state, we are all danger. Don't think we are all same boat. Don't think we are happy with the other part, it will not happen something. This part is only sinking, other part is not sinking. That is not way. Whole society, you have to think the green philosophical part, what people are thinking, what green chemistry is doing. You have to think that is very much important. So chemistry has an important role to play achieving a sustainable civilization on Earth. So without chemistry, very difficult to survive. That is true. That is very much true that we need chemistry, we need product, we need industry. All things are we need. Without this, modern civilization cannot proceed. But how can do? That is very much important. So we need to design the tomorrow. So how can we design tomorrow? By sustainable way. So simple definition is that meeting the need of present generation without compromising the need of future generation. What does it mean? Whatever you need, we have to generate now. Don't take from the future. For future, you have to keep all these things for future person. For your kid or whatever thing, you have to keep this one. Don't take like coal, like energy. So whatever we are like taking coal, this kind of oil, this kind of things. But you have to, if you want to sustain in future, don't think this kind of coal or oil. We have to generate by own way. That's why there are several ways we can generate by this way. Only green chemistry can solve this kind of things. So otherwise, basically, what about no? We have to think about present in such a way that future, the past will not be problem. That is simple way. What we are thinking, what we are doing in such a way that your future, your past will not be any problem. That means we have to generate resource in the basically in present, not for don't need to take from future. So there is another figure that is very much important. So what does it mean? So basically, what do I know? This figure is basically very much significant for all of us. So when you basically when you buy during when somebody is born, so this figure is very much important. So yeah, so all of us parents or God, whatever you say, they gave us this much unit. So what is unit? I'll discuss later. So only maybe that is one kind of unit, 29,200 unit. That is basically close to this unit, not exact this the figure, close this figure. So basically, what about no our our basically what about no our living age is basically what about no almost 80 years. Now, if you compare 80 years, if you just multiply 36, almost this is the days. So every day basically what about no we are losing one day. That means you have to think how we can basically utilize this one day or this much unit. We have to think just judicially this figure. So that is our basically almost our entire life. If you alive for 80 years, that is almost that is the unit. 29,200 days. So each day we are counting. So before that, whatever you need to generate, you have to generate your entire period. Don't need to take of the future. That is the basically philosophy. So as I told you, without chemistry, we cannot survive. Very difficult to survive in modern days. So basically, what is the contribution of chemistry? As you know, chemistry for material science, they are giving a lot of materials. For every day, we need this kind of material. Fertilizers, also like life-saving drugs, also basically agrochemicals. But we need these kind of things. Without this kind of thing, very difficult to survive. What I told you, 80 years, nowadays basically what about our average life is going to increase. What is the basically benefit of chemistry? Also, just use of life-saving drugs, these kind of things. So we need to produce this kind of thing for our survival. But how we can basically synthesize these kind of things? That way basically what about that is the green chemistry. So that is kind of drugs, that is Taxol, that is basically life-saving drugs, cancer, also tuberculosis, that is streptomycin, that is very big drug. So big molecule, we have to synthesize laboratory. Maybe that are, if you compare the total synthesis, that is maybe 36, 70, even 50 steps are also there. For each and every step, we have to calculate the green matrix for our survival. So for fertilizer, as you know, ammonia, that is very much important for fertilizer. And also from ammonia, people are preparing this one urea. That is the basically very important part for agrochemicals or basically what about this kind of things. So that is a very much important, as I told you, Haber process. So nitrogen from nitrogen, hydrogen, just mixing together, and that is the basically what about the reaction condition or optimized condition. What do we say? So iron catalyst, atmosphere, then people produce this kind of ammonia. From ammonia, people are using nitrogen fertilizer. That is the basically important. So why that is important? That is simply we can say that denominator of the population explosion. So using this one basically what about fertilize basically what about our population is increasing. Like that is a simple graph. How do we can say this one? That is our world population. So look at this one. That is world population. This one world population. This one almost close to this one 17,000 millions population. So what is the benefit of Haber process? Haber process. If you think this one. So if there is no Haber process, if there is no nitrogen fertilizer, now compare this one basically our population might be like this one. Almost half of this our present population. So we can say just using this one Haber process by process of preparation of ammonia that increase the population. That is very much significant figure. Almost without this one, without this one Haber process, just our population should be almost greater. That should be half of our present population. That is very much important. So that is herbicides. People are doing this one. That is also basically chemistry product. People are synthesize this component and they are treated this one. If you nowadays if you don't treat this one, looks like this one. If you treat this one, basically what about your production will be high. So that is basically what about now. We can find out there are a lot of benefits for chemistry. So either in disadvantage of chemistry, yes, there are a lot of disadvantage also chemistry. So minimize this kind of disadvantage, we need the green chemistry. So can you identify this picture? So very difficult to identify this picture. So we can see this the fire. That is so many things happen. Basically, what about that is one kind of river in USA, Chihuahua River in USA, that is so polluted that it caught fire. So can we stop the chemicals or production of chemicals? No, we cannot stop the chemicals. But what we can do, we can stop the pollution of environment of the river. So how can do stop the pollution? That is the green chemistry. So another example is that basically that is very famous Van Gogh sunflower canvas. That is very famous canvas. So as you think this, that is a bright color, bright yellow color. So historians believe that Van Gogh died due to the toxicity of cadmium sulfide. So as you know, cadmium very much toxic. So when you are using this kind of pigment or this kind of chemical, we have to think what is the demerit of using this kind of things. So that is the basically what about demerit. So other way basically what about as you know, Bhopal gas strategy, it happened in India in 1984. So almost there are a lot of people they basically exposed by methyl isocyanide. They officially died almost close to 4,000. Lot of people, as you know, that is the basically what happened. Almost all students, all faculty, they can understand the basically Bhopal gas strategy. So people will think whether there is any alternative way to prepare this kind of things. Yes, there is also alternative way. We can think that is the way. So how is the alternative way? So do chemistry in such a way that we can prepare green case sustainable way. So Paul Anastar, John Warner, basically they coined these kind of things in 1991. There are 12 principles, set of 12 principles. They are doing this. They are basically what about a set of 12 principles. By this way, basically, if we follow this one, then we can survive in the modern way. So what is told basically there are 12 principles. By remember, we can think simply by just productivity. Like if you see this one product, prevent the waste, renewable or that is simple way we can think just productively. The product, if you think there are 12 principles, almost all you know these are the 12 principles. That is all textbook, all things nowadays that is very much that is discussed in several ways. So main thing is that basically what I want to. This is the better to prevent waste than to treat the waste after it is formed. So main principle is that basically what I want to prevent the waste, then you treat the clean. So what the philosophy of the part is that. So what we are doing, so after doing reaction, so basically byproduct, solvent, lot of things, we are basically going to dispose this one. So how we are thinking how we can dispose think this one. So that is not way. The way is that. So before using this one, we have to think how we can do the green chemistry, green way to basically to generate the waste. So what I'm thinking simple is that. So maybe you get cold. So we are thinking we need to go doctor, this kind of things. So main philosophy part is that before getting the cold, we have to take the precaution so that we do not get the cold. That is the main way. So before generating anything, basically after accident, we are thinking how we can stop the accident. No, before accident, we have to think to prevent this kind of accident. That is the main part of our life, main part in our also philosophical part. So before anything happen, we have to think we should stop this kind of things. That means what we are taking. So before generating this kind of waste, hazardous chemical, these kind of things, we have to think. So we have to develop such process how can stop the generate this kind of thing. That is the main philosophical part. By this way, basically, we develop something just 12D of principle. Same thing, but we are own way. We develop this kind of principle. Decrease the waste. Simple. If you just decrease the waste, basically, whatever no, we can save lot of things. Just remember this one. So after reaction, how we can decrease the waste. That's the main important part. Also, there are that all things are basically designing methods, incorporation maximum starting material. That means atom efficiency should be almost close to 100%. Designing the product with no or lost toxicity. There are so many things, as you know. Just from productivity to we are basically just moving 12D. Remember this one. 12D, that is they are designing that decrease the use of auxiliary, decrease the energy requirement. These are things basically if you remember this one, that is the simple way we can remember 12D of principle of good chemistry. That is we develop this kind of things. So green chemistry basically what about no? That is simple way basically there are 4 R is there green chemistry, that is simple way basically reuse. We have to reuse the byproduct or what we are generating this one, that is reduction of our waste, recycling, also recover. That is simple 4R. We have to remember this one 4R. That is good for the green chemistry. Like this way, disposal, treatment, recycling, prevention, basically and reduction. So that is the main part. We have to prevention and reduction of basically to generate the hazardous materials. Also reuse whatever it is generating, whether we have to think whether we can reuse or not. And treatment, also generating this kind of, if it is not possible at all to stop the hazardous materials, we have to think how can treat this kind of hazardous material for the safer life. Also finally, whatever you know, if you cannot treat at all, we have to dispose of this kind of thing in safer way. That is nowadays basically nowadays this kind of like medical waste nowadays very much this kind of going on all newspaper, this kind of thing, you think the medical waste. That is also proper way you have to dispose. That is very much important. So for all life, we have to think how we can dispose. So we are going to market, we are getting a lot of plastic bag and we are basically we are throwing maybe around the environment. That is not good way for dispose of this kind of things. That's why if you want to buy biodegradable polymeric bag, that is good. Otherwise, we have to carefully dispose these kind of things. And similarly, basically, we have to reduce waste, material, hazardous risks, and so energy cost. These are the basically industrial method, industrial process. We have to think this kind of things. So when we develop this kind of green chemistry, we have to careful these kind of things. Catalysis, solvent for all kind of reaction. So as you know, catalysis, solvent, also energy, these kind of things very much important. So we need to think when you develop one reaction, we have to careful what is the reaction conditions. That is very much important. Also, what is your starting material? Also, after finishing the reaction, what kind of product you are getting? Very much important. So I just previously discussed. So what happened in 1984 Bhopal? So as you know, Union Carbide India, they prepare to this kind of things. Basically, what I want to, that is one kind of basically insecticides or pesticides. That is carbyl or sevin, that is known. So as you know, that is beta naphthol, that is basically alpha naphthol, quite famous, and that is one kind of amide. So as you know, how they prepare. So this gas, phosgene, this gas is phosgene, that is basically carcinogenic, hazardous for our health. And if you treat well methylamine, then we can get also basically isocyanate. That is also basically carcinogenic, reactive species, lot of things. So how they prepare, if you take alpha naphthol, that is alpha naphthol. Now if you treat with this one, then we can get basically whatever you know, then we can get this one, this kind of our basically insecticides or pesticides. So that is the way. So what happened on that day, basically probably that phosgene, that is also basically very much dangerous, carcinogenic. It reacts this one also, they store this one, and before doing with this one, they store this kind of, you need to store this one, that is very much reactive. In place of water, explosion can occur. So probably on that day, basically this methyl isocyanide, they leak out and also spread out the whole city, whole the area. That is the basically main culprit for this kind of disaster. So now green chemistry people, they are thinking, so whether is there any alternative way we can replace this method. So that is basic, we call basically what about, that is first generation. First generation means that is the basically what about, very beginning they used to prepare this kind of methyl isocyanate, this one, that is carcinogenic, that is two things are carcinogenic, two parameter carcinogenic. So now basically that is your product. So how do you think basically what about, if you treat there, if you now treat with this one, that is basically what about, you can get this one. Now if you treat with amine, then you can get this one. So that is basically one way, basically what about, by this way we don't need to generate the methyl isocyanate. That means we can basically eliminate one part. So next, our target is to eliminate two parts, that is phosgene as well as methyl isocyanate. So how it now, if you treat with this one, basically dimethyl urea, then we can basically whatever we can do this result. That means we can use this one without any toxic methyl isocyanate or phosgene gas. That is the green way we can prepare this kind of insecticides. That means green chemistry, basically using green chemistry method, we can prepare this kind of insecticide or this kind of pesticide, this one. So what we are talking about environment problem, as you know, that is nowadays basically a lot of things are environment problem. So environment problem also basically that is also different, that is also philosophical part. It depends on the area, depends on the human being, depends on the city, depends on the lot of situation also. So that is simple example basically what about, people are using pesticide DDT. So that is DDT. So interesting is that DDT basically what about, in lifetime is very basically longer lifetime. So that is not good for the environment. So many advanced countries, they are not using this kind of pesticide DDT. So instead of basically what about, but in malaria infested area like Africa, basically they need that kind of DDT. That means what about, in one area in America they know DDT, but in Africa they need DDT. That means basically what about, depends on the situation. Basically what about, we are calling this one environment problem. But fact is that DDT basically not good for environment. But for Africa still they are using this kind of thing. So for that, what about, we need to develop biodegradable basically pesticides. People are thinking how they can develop this kind of pesticide in biodegradable way. So as you know, Rachel Carson, basically what about, writer, scientist, ecologist, basically all of you know, probably you have read this kind of book, Rachel Carson, Silent Spring, that is basically famous book. So all of you know. So what about teaching? So during our teaching, so basically what about, we have to basically what about, you have to use some technique. So how we can teach the students. So basically, so learning objects would be our basically in respect to basically towards the green chemistry. To consider the sustainability, what is sustainable? So we have to discuss this one. Also, how we can understand to apply the concept in our research of interest aiming the shape of our plant. So when we are giving some example, we have to basically what about, always discuss. So what is the basically what about, what is the advantage of green chemistry? What is the part of hazardous part? We have to clearly mention in blackboard or when we discuss, when we basically teaching this kind of thing. So I can give you one example. That is basically all you know, that is a Grignard reaction. All 12 class standard people know that is basically Grignard reaction. What is Grignard reaction? That is basically that is RMGX. People are using this one Grignard reagent. And if you prepare this kind of alcohol, so how can prepare secondary alcohol? So people are writing this one on blackboard. Okay, aldehyde. If you take RMGX, put water, then you are getting product. In class 12, basically what about, you will get full marks. Even also honors subject, you will get full marks. That is one example of green chemistry. So when you do in laboratory, that is basically what is that? That is textbook chemistry. That is textbook chemistry. How we are just writing on blackboard. But when you do the reaction, there are a lot of things you have to remember. So if you do this kind of things, you have to take magnesium. Then you have to activate this one. Then if you add this one drop by drop, this one, basically that is halide. Then we can generate this one Grignard reagent. That is Grignard reagent. Now that is solvent THF, tetrahydrofuran. Next we have to add Grignard reagent to aldehyde. Then we can get this one Grignard reagent OMGX, basically one kind of product. Now you have to put water. Then basically whatever we will get product. RMGX. Then after workup, lot of things, then you will get good product. Then after purification, we will get basically final product. That means if you don't know these kind of things, very difficult to discuss the green chemistry part. So on textbook, we are writing this one, just using this one reaction code, you will get this one. But when you think in laboratory, we have to each and every step, we have to take the care. So during workup, we have to take care how you can do workup. So for organic people, probably those who are the PhD students, they know how can do this one, workup this one. So workup basically what about no organic layer is there and also water layer is there. You have to take out this one, then you can do work on. And purification, column chromatography, recreation, lot of things are there. During purification, we are doing lot of solvent. Then you have to think that is corroding solvent or non-corroding solvent. Also, how can dispose a lot of things. Industry, they are thinking. That means if you want to develop one reaction, we have to careful lot of things. Also, when you discuss in blackboard, we have to tell something how this we are getting this kind of product. Otherwise, very difficult to get into this kind of green chemistry. So another way is basically what about no example of green chemistry. So you have to that is basically what about that is one kind of basically alcohol. That is how can prepare this one this kind of allylic alcohol, that is allylic alcohol. How can prepare in textbook basically what about if you take this kind of allyl chloride, if you put water, then you can get this one allylic alcohol. Okay, that is fine. But problem is that you are getting byproduct HCl, that is chlorinated HCl, but that is not good for the basically, that is good for the environment. So how can avoid the chlorine? So there is simple way. If you take this one basically what about this kind of chemical, if you put oxidation of this one, then you can get acidated. After that basically what if you hydrolyze, then you can get this one allylic alcohol. So what the benefit? That is the green note. That the green note we can avoid this kind of things, corroding solvent, and also we can discuss the added benefit is that we are producing acetic acid. That is we are calling this one glycerin. That is vinegar, one kind of vinegar. Anyway, in vinegar that is also acetic acid. We are using this one. So by this basically what we get example to the student. What is the green part? How that is there an alternative way or not? That is main motto of our teaching. So in every reaction, we have to think there is an alternative way or not. So that is simple way of benzoin condensation. So people are using this one, potassium cyanide. That is so potassium cyanide. You know that is basically what about how basically what about high carcinogenic this one potassium cyanide. So you have to think so alternative way. So yes, there is alternative way. So if you use this kind of coenzyme, basically what about that is basically coenzyme. Then basically what about we can do same reaction. So for each and every step for the students, we can give this kind of example. So also other simple example is that basically this one basically Fieldcraft reaction. So as you know, Fieldcraft reaction, that is simple Fieldcraft reaction. We are using aluminum chloride. That's all chlorinating. After reaction, we are generating this one HCl. So you need to avoid this kind of basically chloro, fluoro. These are not good. So you have to basically avoid the use of chlorinating substrate, chlorinating basically chlorinating the byproduct. So we can generate this one. If you take this one one kind of anhydride or the other way, basically for all cases practically not possible. But we can think how can improve this kind of methods. So other interesting example is that chromium dioxide. So that is a simple allylic alcohol. So if you put chromium dioxide oxidation, then we can get basically ketone. But simple way basically what about nowadays in place of some catalyst and oxygen, basically we don't need to chromium. Chromium, as you know, chromium is carcinogenic. So we can avoid the chromium. Then we can do simple oxidation, that is aerobic oxidation, then we get ketone. So what I told you basically that is interesting. That is the fact is that basically almost basically 1956 people are using chromium from oxidation. So what they did, say they want to prepare some quinine drug molecule. They want to oxidation using chromium. But instead of this one basically they got some basically diester, that is pigment. One pigment is that basically that is the interesting is that the first synthetic diester, mauve color, looks like this one mauve color, and also basically by this way basically so as you know basically when you are doing basically dye test, as your dye test we are getting this kind of color. So this idea from this one basically Hodabano, this leads up to the birth of chemical industry. That means after that, chemical industry generated, people are doing a lot of dye stuff. Also, now chemical industry, basically now cotton, this kind of thing, they are using this kind of pigments. So why chromium is dangerous? So if you look at the structure of chromium, basically chromium is hexavalent, look like basically one kind of sulfate. So now if you eat a lot of chromium, as I told you, chromium is toxic and also basically carcinogenic. So look like this one chromium, that is looks like sulfate. That is basically Hodabano. That is the easy way get into a DNA, so that basically pass double anabolism kit. That means a lot of we need to avoid the chromium. So that are a lot of things we are discussed. So nowadays basically present scenario basically Hodabano, green chemistry, they give a lot of things for us, for industry. So paper industry, as you know, basically Hodabano, that is basically lignification, that is very much important. Basically, you need to get the white paper. So previously people are using this kind of bleaching, basically Hodabano bleaching using chlorine based reagent. Nowadays basically Hodabano, we don't need this kind of chlorine based reagent. We need just if you add this kind of this one tetraamido ligand in place of peroxide, then we can use basically Hodabano to lignification of paper industry. We don't need basically Hodabano this kind of chlorine reagent. That is basically Hodabano advantage of Hodabano we say. And also basically Hodabano traditional ibuprofen, that is basically analgesic. So nowadays that is one of the important drug. Almost 30 million pound of ibuprofen are generated every year. So now Hodabano, if you look at the atom economy, 40% previously it was. Nowadays Hodabano, we can change this one basically Hodabano. Like green way, people are generating this one 77%. That is basically that is cost effective. Also with the state economy, lot of things are happening these kind of things. This one basically poly basically what I told you in the beginning basically Hodabano, that is basically biodegradable polymer. We can prepare from basically from crops. We can prepare this one easy way. We can crops biodegradable polymer. We can use this one. So now when you discuss everything Hodabano, so solvent is very much important. So in our laboratory, so every day basically Hodabano, every time you are using solvent for the reaction. So think about the aqueous reaction condition. So interesting is that our body, almost all reaction going on the aqueous media. So as you interesting example is the radical reaction. So people thought that so water is not good for the organic reaction or all kinds of reaction. But interesting is that radical reaction, what is the good solvent for radical type reaction? Think about our own system. So like our own system. So when you are doing basically antioxidant, these kind of things, antioxidant nowadays basically like COVID people are doing antioxidant. What is antioxidant? So basically when you take oxygen, this oxygen basically going to triplet to basically what we are taking oxygen, that is triplet oxygen that convert basically singlet more reactive pieces. If you take antioxidant, that can destroy this one. That means reaction is going on basically water. So you have to think how our body basically suitable for aqueous system. Also nature is suitable for aqueous system. Now why not in our laboratory? So we have to think our laboratory whether we can do this kind of things or not. So that is one interesting example. So we can do reduction like simple carrot, green way you can prepare this one, reaction of this one. So yeah, sure, I'm going to finish. So alternative way basically so in our laboratory we are doing basically we are doing this kind of practicing this kind of like Lassine test. What we are doing basically sodium and a lot of things are then this one heated this one. So there is also alternative way we can do this one. So any undergraduate laboratory, also postgraduate laboratory, they can use. There is one book monogram of this kind of green chemistry book. So we can take this one. Also there is the one book that we can do. That is a way. That is just going to the last part. What I am doing basically in our laboratory. Just 1 minute. Subhankar, 1 minute. Yeah. So 1 minute. So what we are doing basically in our laboratory nowadays basically electrochemistry or photochemistry. That is very much basically important, photochemistry. So why people are thinking photochemistry? I started my lecture from just giving one example of photosynthesis. Photo means light, synthesis of built up chemical synthesis. So our now people are thinking, chemistry people are thinking how we can do reaction basically in presence of or basically in place of this kind of sunlight. That is basically photochemistry. So you will look at the photochemistry, how chlorophyll is do. Chlorophyll basically how to absorb solar energy and also become charged and activated. That means you need some pieces that can absorb basically whatever that can absorb solar energy, like our body basically cannot absorb this. Our body basically when your UV light basically whatever that is basically whatever more reactive light that is destroy our DNA or this kind of things. But visible light they cannot this kind of things. So now presently whatever no people are doing visible light mediated photocatalysis. Lot of things are example is there. We can discuss later when we get time. So by this way, basically people are using sunlight. Also electrochemical. Electrochemistry means basically whatever no. So people are using chromium, that kind of things for oxidation. Nowadays, basically whatever no, people are using this one electrochemistry. That electric energy then converted to the basically chemical energy. That is very much important. So what about our thinking of chemical industry? Previously, we thought that is part. So many fumes, lot of things are there. So now today basically what about using green chemistry? What about loud tree are there? Also that is green environment is there. And also tomorrow, what you are thinking now? Industry also like environment residential area can be in the same area. That is our target. Also we can do sustainable development by this way. When you think that energy that is very much important. That is the main part of our. So in nutshell, we can say green chemistry, sustainable chemistry. It is not a solution to all problems, but the most fundamental approach for the prevention. That means basically seek prevention, not cure. So we can basically we can prevent a lot of things than cure. So that is the basically chemical is our integrated part. We need this one. But philosophical part is that how can generate this kind of chemical, how can treat this one, how can use this one, that is very much important. So academia and industry, we should shift their attention toward the green and sustainable way by choice. Or also finally, our daily life, what we are thinking, our daily life, our views should be also changed in the green way. So when we go for shopping, so at least we should carry one bag. Not we don't think about this kind of plastic things. That is the message for our. That is the good. Also, finally, I would like to thank the organizer for organizing such kind of webinar. Also, finally, I would like to thank my PhD supervisor, Professor Krishnanu. He started green chemistry long back, maybe from almost 1990. He spread out this kind of green chemistry idea in almost in India. And finally, I got the money for doing out this kind of research, CSR, BST, also Vishwavardi. Thank you very much for your kind suggestions. And thank you.
Nice lecture, all of that.
So thank you, sir. Thank you for your informative session. We learned many things in our lecture. That is from the beginning, the bad effects of chemistry, 12 principles of green chemistry, importance of green chemistry, and effect of HEPA process and methyl cyanide, vocal gas accident, and bad effects of DDT, green routes of synthesis, and almost all things you have covered. If I want to ask the audience to, if you want to ask any question, so please.
No, I know that is simple chemistry. So almost people understand that is the basic things of green chemistry. I think there is no
simple chemistry. Alauddin, how are you?
Fine.
Yesterday I tried to call you, but it was not connected. Anyway.
Okay.
Good to see you after a long time.
Yeah. Okay, I can stop now.
If there is no question, I again wish to thank to the speaker for the informative session. Thank you, sir, and stay with us.
Thank you, Subhankar, for giving this opportunity. Also interact. My junior is there, Subhas. Also, probably I can see the Suikot. Suikot probably he's not here.
You have covered. You have covered almost everything. So I don't
No
have
one
to.
saw us. So you are. Yeah, hello, Saikot.
Hello, Alauddin. I can hear you well.
Okay.
How are
Okay,
you?
see you later. Just now, I need to start other things. You need to start other things. Okay,
Yes.
go ahead.
Yes.
Okay, sir. For the next session, I want to invite to chair the session by our another convener of this seminar, Dr. Alauddin Dafadar, a head of the Department of Mathematics, Bhatter College, Dantan. Dr. Dafadar, over to you.
Good evening to all of you. Am I audible?
Yes, yes. You may start.
Thank you, Dr. Sardar. I am starting as a moderator of technical session 2. In session 2, our next speaker is Dr. Subhash Banerjee, Assistant Professor, Department of Chemistry, Guru Ghasidas University, Bilaspur. Welcome, sir.
Thank you.
Before his lecture, I wish to introduce Dr. Subhash sir to our participants. Dr. Subhash Banerjee completed his MSc from the University of Bardwan, West Bengal, India in 2002. Dr. Banerjee has completed his PhD in synthetic organic chemistry from Indian Association